May 11th, 2026, the hacker team called Team PCP launched coordinated attack against an open source ecosystem. For those of you who don't know what TanStack is, it's a set of packages for JavaScript and it's extremely popular. The React router itself gets 12 million downloads a week. But this is not what makes this incident unique. What makes it unique is the fact that all the packages influenced were looking perfectly safe. They were even attested according to SLSA build level 3, which is pretty high. And yet, the malware were there. 2 OpenAI employees installed these packages on their machines, and their credentials were exfiltrated. No client data was exposed. Luckily, but it's besides the point. And the point is, your build pipeline is not a safe place anymore. It probably never were, but currently definitely isn't. This is not because your code is bad. This is because the things you used to trust are not safe. The attestation, a package, the pipeline itself, or even your Dockerfile. Hi, I'm Pasha. I'm a developer advocate for Bellsoft. I'm a backend developer, and I'm a person who reviewed a ton of Docker files and made a lot of mistakes there. And hopefully, I won't do it anymore. Are you with me? The thing is, most Docker files are written in a paradigm which is just irrelevant anymore. They were written in a world where you could trust your dependencies and where you could trust your pipeline. This world is gone. It's just our Docker files didn't catch up yet. Today, I want to tell you about 8 crimes which you can commit in your Docker files. And when you know them, you can solve them one by one. By default, most containers run as root. Not because of someone's bad decision. This is just a default for Docker, and we didn't think about changing it. For example, look at this TanStack attack. The attackers used npm install, which just installs packages in npm, but actually it also calls post-install hooks, which can execute any random code. What it means is, if they have created something with the root privileges and your container is somehow compromised, they don't need to have privilege escalation. They already have root in your container and probably on your machine. And the way to fix it is beyond trivial. Add user and then user this user. That's all. Now everything is being executed from a normal user. The crime number 2, and it's kinda hard to believe that I'm talking about it in 2026, but probably it's still news for someone. Be extra careful with sensitive information during your build. Do not use build arguments with your tokens. Do not hardcode them. If you really need to use them, use mounts of type secret. That's all. When you do some kind of run, mount secret, ID of this type, and you're good to go, you can use your variable. And for the runtime secrets, that's why we have env directive to not expose our tokens and passwords. Remember, everything you have in a Dockerfile resolved at build time will be there in manifesto. Crime number 3 is bloated Docker images. This one is kinda more philosophical and slightly harder to fight, and that's why we have our own hardened images, for example, available on Docker Hub. But the main idea is, the more things you have in your production image, the larger your attack surface is. So, if the next time you will decide to call gradle build on the last stage of your Dockerfile, for God's sake, stop, you shouldn't do it. That's why we have, first, staged builds of our Docker files, second, Slim-based images, third, hardened images. Number 4, be extra careful with using latest tag. The thing is, latest is not a tag per se, It's more of a pointer, and you never know to what this pointer points. It can point to the new version of software, and you will get more features and more security updates. It also can point to the newly published infected version of a software. It also can point to the version of a software which is incompatible with your whole project anymore. So, please pin actual versions. Probably you shouldn't even pin versions, probably you should pin SHA 256 hash sums. Because this way you will know certainly that the image is not replaced by something else. And then use bots like Renovate, for example, which will tell you, hey, there is an update for this image, here is the new hash sum, do you want to update to it? And you will be able to make a conscious decision if you want or not. Crime number 5. This one actually won't destroy your security. It will probably destroy your will to live. This is bad layer caching. Picture this. You have a Java project with Maven, and every time when you change a single line of code, you're copying your source code to your Docker image and you're calling Maven package or Maven verify. It is clean, but there is an issue. It downloads all your dependencies every time, and it can take quite some time actually, multiplied by number of developers in your team and number of times you build it on CI or locally. And it's a crazy amount of time. You can do better. You can actually copy home XML first, then you can call Maven dependency go offline, and then on the next, you will copy your source code and you will actually call Maven package. This way, you will save all the time you would need to download dependencies, including testing ones. Isn't it beautiful? Crime number 6, I usually mention in my talks, is deploying a fat jar into your production layer. You're not supposed to do it, it's inefficient, it's slow, it requires an enormous amount of traffic to deploy your software to all the servers. You can do better. What you can do is to enable layered jars and then copy dependencies launcher and only at the last layer your application to your production stage, and this way you will save an enormous amount of space, because usually the whole difference between previous and the next version of your Docker image will be one layer containing only your application, which is most probably like several megabytes maybe. A thing which I often see in many production-grade images is the crime number 7. In many images I see apt-get update, apt-get upgrade, or Alpine alternative to them. And I get the intentions are good. I want to update all the software to get all the latest patches and so on. But the thing is, in this setup, nothing is pinned. We can do so much better than this, because imagine we update libc in our Docker image and our application is not compatible with the new version for whatever reason, or some other library, libpng for example. You're not supposed to do it. It takes time, it takes space in your image, and it is unstable. You're trading kind of security for instability. What you should do instead, you should use base images which guarantee compatibility of software inside. Or, if you have to install something on top of that, please pin versions. In Ubuntu, for example, you can say apt-get install my dependency =, version number. This way, this at least will be stable, and when this dependencies is not available in repositories anymore, your build fail as it should, because you will have to test against the new version of the software you are depending on. And the crime number 8, putting developer dependencies inside the production image. I actually committed this crime many times, and now I do realize that I was wrong. I'm sorry. I get it. You need this call inside your image, so when you're on call and someone calls you and 2 a.m., you have an easy way to debug something. You call this Docker exec inside your Kubernetes or whatever, and you see what's happening. But the thing is, the minute you put code there, you actually opened a huge surface of attack. If attacker can have access to your image with curl, they can do something malicious. They can download something. The same goes for any other developer tool. For example, Java Debugger. What could harm? Did you know that with Java Debugger, you can actually change code inside a running application? Imagine attacking do so. And don't even get me started on interpreted languages like Python or JavaScript. Attacker could just rewrite something. So if you can avoid having editor inside your image, please do so. Probably you want to use testreless images to avoid this attack vector. Let me bring this together. Root. Unpinned dependencies, development tools in your images. They all are the artifacts of the situation when you trust. You trust your CI pipeline, you trust your developers, you trust your ops people. This is not the case anymore. It all should be as zero trust as possible. If there is a way to avoid exposing an attack vector, we should use this way. And TanStack is just one more example of how we shouldn't trust anything, including our CI pipelines. I made a lot of mistakes. I'm trying to learn. Please be smarter than me. Learn on my mistakes, not on your own. With this, if you like this video, like the video. If you have something to say, say it in the comments. And Pasha out!